beneath the Red Sea's surface, something exists that defies every law of nature we thought we understood. Something so profoundly alien that it's forcing us to reconsider everything we know about life itself. Not just on Earth, but potentially across the entire cosmos. Picture this. 8 hours into their mission, the ocean explorer's submersible had found nothing but an endless expanse of lifeless sediment, stretching into the perpetual darkness. The crew was moments from calling it quits, from beginning the long ascent back to the surface. Then, the headlights caught something in the distance, something that made no sense whatsoever. At first, it looked like a dark mirror lying flat on the seabed, roughly 20 meters wide. A thick fog seemed to hover above it. As they crept closer, their instruments confirmed what their eyes refused to believe. They were staring at water. They were already underwater, a mile deep in the Red Sea, and yet there it was, a lake. An actual lake, with gentle waves lapping against a beach at the bottom of the ocean. Only a handful of humans have ever witnessed this sight, and what they discovered next transforms this geological oddity into something far more sinister. Anything that ventures below the surface of that strange water never resurfaces. Ever. Yet, somehow, impossibly, in this realm of absolute darkness and death, life exists. Not just any life, but something primitive and utterly alien, thriving in conditions that should obliterate any living thing. By 2025, thanks to a cascade of remarkable discoveries, these surreal underwater environments are revolutionizing our understanding of how life exists on Earth, and perhaps, terrifyingly, beyond it. But we're getting ahead of ourselves. Let's rewind to where this story truly begins. March 1st, 1964. Buried deep in a scientific journal, taking up barely a quarter of a page, is humanity's first recorded encounter with the impossible. A humble English oceanographer named Henry Charnock had discovered what he cautiously termed anomalous bottom water, 2 kilometers under the Red Sea. Try to imagine what Henry must have felt when his instruments confirmed that a lake existed at the bottom of the ocean. What it was, why it existed, he had no idea. He just knew it was there. Impossibly there, defying all logic. Without realizing it, Henry had stumbled upon something that would forever reshape our understanding of life on this planet. While he couldn't explain the water's origin, he noticed something peculiar. It was incredibly salty, far saltier than the seawater above. This seemingly trivial observation is actually our first clue to unraveling this impossible mystery. Here's where physics gets wild. The more salt dissolves in water, the denser it becomes. That's why you can float effortlessly in the ocean, but sink like a stone in a swimming pool. The ocean's higher salt content makes it denser, so, relatively speaking, you become less dense and bob to the surface. The same principle applies to these underwater lakes, except magnified to an extreme degree. The water in these formations, which scientists call brine pools, is so saturated with salt, so impossibly dense, that a submersible literally bounces off the surface like hitting a trampoline. If you could somehow breathe and survive the crushing pressure down there, the lake's surface would feel like a giant waterbed beneath your feet. You could, theoretically, walk on it. These brine pools can stretch up to 20 kilometers in length, forming majestic underwater lakes, rivers, and even waterfalls cascading in slow motion. But here's the really mind-bending part. They can reach hundreds of meters deep. We're talking about massive bodies of water within water, complete ecosystems existing in a liquid within a liquid. But wait. If you've ever added salt to a glass of water, you know it doesn't sink to the bottom and form a layer. It just dissolves, right? So what prevents these brine pools from simply mixing with the surrounding seawater? Why is there such a razor-sharp boundary between them? The answer lies in two natural processes working together in perfect, eerie harmony. The first is called double diffusive convection, and once again, Henry's sharp observations provide the key. That anomalous water wasn't just unusually salty, it was unusually warm. So imagine, at the very bottom of the sea, you have this warm, supersaturated brine. Directly above it, cooler, less salty seawater. Both heat and salt want to diffuse upward into the cooler water. In theory, this should mean the brine just dissolves away into the ocean. But here's the twist that makes everything click. Heat spreads 100 times faster than salt. Heat wins the race every single time. This means the seawater directly above the lake's surface absorbs heat and becomes warmer, causing it to rise away from the boundary.
Meanwhile, the brine just below the surface loses heat and becomes cooler, causing it to sink deeper into the lake. The result? The top layer of the lake wants to move down and deeper, while the seawater above wants to move up and away. This creates that impossibly sharp boundary, that surreal tide line that makes it look like an actual lake underwater. But eagle-eyed readers might spot a problem here. Even with that sharp boundary, salt is still crossing the line, meaning the lake is constantly losing brine to the water above. By all rights, the lake should evaporate away over time, like a puddle in the sun. So why doesn't it? Because these aren't static pools, they're alive in their own way, constantly in flux. Just as brine vanishes into the water above, it's being replenished from beneath. The lake exists only because of a delicate, almost impossible balance between these two opposing forces, one trying to shrink it, the other to grow it. But where is this endless supply of warm, salty water coming from? You've heard of plate tectonics. Now prepare yourself for salt tectonics. Scientists wrestled with this puzzle for decades before the answer began to emerge. Across the entire planet, brine pools exist in exactly three places: the Red Sea, the Gulf of Mexico, and the Mediterranean Sea. All three share one crucial characteristic, a bizarre geological feature that allows these pools to form, and understanding it requires traveling back in time. During the Jurassic period, the Gulf of Mexico was sealed off from the Atlantic Ocean by a narrow land bridge. Over 100 million years later, the Mediterranean suffered the same fate. By then, the Red Sea had also been cut off from the Indian Ocean. When these seas became isolated from the ocean, they transformed into giant basins. With no fresh water flowing in, the trapped water simply evaporated over time, leaving behind something extraordinary: thick deposits of pure salt, kilometers deep in places. Over millions of years, those salt deposits were buried under countless layers of sediment, pushed deeper and deeper into the Earth's crust. When those dried basins eventually reconnected with the oceans and filled with seawater again, they created a unique and volatile geological setup. Above, ocean. Below, an enormous compressed layer of salt. Only a layer of sediment separates them from meeting. And then, the magic happens. As sediment continues piling up over eons and the salt gets buried deeper into the Earth's crust, the weight becomes astronomical. The sediment on top becomes so heavy it starts squashing the salt underneath, forcing it to shift and flow like a viscous liquid. This process, salt tectonics, causes warping and cracking in the sediment layer above, allowing seawater to slowly seep down through the fractures and mix with the ancient salt below. The result? An ultra-concentrated brine forms deep within the Earth. As the sediment continues to shift and buckle, that deep underground brine, heated by the Earth's internal temperature, gets squeezed upward like toothpaste from a tube. It erupts onto the ocean floor and settles in the lowest depressions. Finally, after millions of years, we have our underwater lake. But brine doesn't just sit passively in pools. During a 2018 dive, NOAA's remotely operated vehicle peered over a low rise in the Gulf of Mexico's seafloor and gazed into the depression below. They found a small pool of dark blue brine, surrounded by the bright white shells of mussels that had fallen victim to it. A graveyard of the damned. But as the camera panned upward, away from the pool, it captured something even more dramatic. Long, blue-gray-black streaks of stained sediment ran down the slope above the brine pool. They were witnessing an undersea brine waterfall, possibly forming over 180 million years since the Jurassic period. The concentrated brine, flowing through geological channels called diapirs, cascades down the seafloor in slow motion, directed toward the low-lying areas where it collects. Imagine standing on that slope, watching toxic water pour down toward an underwater lake of death, knowing that this waterfall has been flowing since before the dinosaurs walked the earth. Now comes the truly unsettling part. What manner of creature could possibly survive down here? At first glance, the conditions seem utterly hostile to life. The shorelines are littered with corpses, fish, crabs, lobsters, eels. What scientists didn't initially realize is that some of those bodies have been there for decades, perfectly preserved in the hypersaline water, like an underwater mass grave of mummified sea creatures. But then they started watching what happened in real time. Fish and eels that wandered near the brine mostly avoided it instinctively, but occasionally one would venture below the surface. Within seconds, violent convulsions would seize their bodies. Fish writhed uncontrollably. Eels wrenched themselves into knots. This toxic shock is caused by extreme salt levels, and it's the fate of any unlucky creature that dives too deep. Their only hope is to rise above the surface, back into normal seawater. Most never make it. Because of these extreme salt concentrations, brine pools are also anoxic, completely devoid of oxygen. At least, not oxygen that sustains life as we know it. And as if that weren't hostile enough, the salty, oxygen-free water is also loaded with toxic methane, which should surely extinguish any remaining possibility of life. This should be the worst place on Earth to live. A toxic hot tub of death miles below the ocean's surface. No oxygen, no light, alone in the perpetual darkness of the deep sea abyss. And yet, there is life. Thriving, abundant, complex life. Vast colonies of bright green tube worms stretch for hundreds of meters in every direction. Giant mussels, some over a century old, pack tightly around the shores. This mussel beach hosts a carnival of bizarre creatures. Shrimps, snails, weird squat lobsters, jelly-like crabs. Even larger predators like fish, octopuses, and cutthroat eels visit the lake in search of food, like a watering hole on the African savanna. But the most successful creature of all? The hagfish. These slimy, eel-shaped fish lurk at the water's edge like patient executioners, waiting for unsuspecting prey to wander into the brine. The moment toxic shock takes hold, the hagfish swoops in and snatches the body. These creatures are ancient, older than dinosaurs, often called living fossils. They're strikingly similar to the very first vertebrates to appear on Earth hundreds of millions of years ago. But recently, scientists noticed something even more curious. Hagfish are the only animals that seem immune to the toxic effects of the lake. While all others die in seconds, hagfish come and go as they please, diving deep into the lethal water to catch their prey. How they've evolved this immunity remains one of the great unsolved mysteries of the deep. Even more staggering than how hagfish thrive is how the entire ecosystem survives, because it's powered by something that should kill everything it touches. Before these deep-sea environments were discovered, scientists believed all life was ultimately powered by the sun. Green plants absorb solar energy and convert it to food through photosynthesis. Animals eat those plants, forming the base of the food chain. This principle even applies in the deep ocean, where sunlight never reaches. Life there survives on marine snow, a constant drift of dead plankton and organic matter falling from the surface, all originally deriving energy from the sun. But when researchers first encountered brine pool environments, they realized they were seeing something fundamentally different. An oasis of life, completely independent from the sun. These creatures had their own mysterious source of life-sustaining energy. So if not the sun, what powers them? The answer lies inside those mussels clustering around the lake's shores. Under microscopes, scientists discovered their shells were packed with bacteria, but not ordinary bacteria. These were specialized organisms with one extraordinary ability that holds the key to the entire ecosystem's survival. They can transform chemicals into food. The specific chemical is methane, and fortunately for these bacteria, brine pools are absolutely loaded with it. This process is called chemosynthesis. Just as green plants convert sunlight into food through photosynthesis, these bacteria can do the same thing with methane, spewing from deep within the earth. The toxic soup that kills almost anything that touches it is actually the very thing keeping this ecosystem alive. Just as photosynthesis is the foundation of life in the sunlit world, these chemosynthetic bacteria convert toxic methane into the lifeblood of an entire ecosystem independent from the sun. The bacteria live deep in the gills of mussels in a symbiotic relationship. In return for energy, the mussels protect the bacteria from predators and provide a stable environment. The mussels, in turn, provide shelter to the shrimps, lobsters, and crabs that feed among them. Such an abundance of life in the middle of a vast, barren, abyssal plain, totally independent of solar energy, astounded the scientists who first discovered it. To them, these ancient life forms seemed like a window into the distant past. And now, in 2025, scientists increasingly wonder, nearly 4 billion years ago, could the first life on Earth have appeared in an environment exactly like this? Previously, the conventional wisdom was very different. In a letter from 1871, Charles Darwin suggested life first appeared in some warm little pond with all sorts of ammonia and phosphoric salts. That's why scientists who study them think they might be the best analog we have of the place where life first began. And to take this a step further, could these alien environments guide the ongoing search for life beyond Earth? While this, after all, is a channel about Earth, not space, let's just take a moment to imagine. If some environments similar to brine pools were to exist elsewhere in the solar system, or even beyond that, it would be as good a place as any to find life. Two of the most likely contenders are Europa, a moon of Jupiter, and Enceladus, a moon of Saturn. This is because beneath their icy crust, they both have vast underground oceans of liquid water. What's more, these oceans are likely as salty as the oceans on early Earth, potentially creating similar conditions to those where life began on Earth. Before the discovery of deep-sea chemosynthetic environments like brine pools, these subterranean oceans would have been written off as unsuitable for life. This is because the layer of crust above blocks out the sunlight, previously thought to be essential to support living beings. But now, it's a far more exciting story. Deep in the pitch-black oceans of these two distant moons, could there be briny oases of life hidden beneath the ice? It's certainly possible. Either way, we'll have to wait at least until the year 2030 to find out, when NASA's dedicated Clipper spacecraft will finally arrive at Europa and begin its search for life. Of course, we're leaning towards speculation here. We simply don't know enough about brine pool environments to make concrete claims that life began under similar conditions, or that they can be found beneath the ice of Europa and Enceladus. What we do know is they completely changed our understanding of how life can exist, and on top of that, there's one thing we can say with no doubt at all. As we continue to unravel the mysteries of these surreal underwater environments, The potential for incredible discoveries only grows. After all, who knows what wealth of secrets might still be lurking below the surface, just waiting to be found.